wideband.
Yeah.
Perhaps the birds that you mentioned possibly have got a very limited vision.
Yeah.
And to camouflage them is fairly simple. You need only restrict the whole thing to a few, very narrow band. So suppose you want to camouflage the human vision, is it necessary to go really for a really wide band?
Yeah, that's a problem. Yeah, of course. I showed you, that's why I showed you a lot of pictures where we had typically between 400 and 700 nanometer, which is not very large, but it is in 300 nanometer band. And there, of course, we have, strictly spoken, not an ideal situation at all kinds of wavelength, but we can create substructures. So we can create this to have several resonant frequencies in order to have these diffractive elements, diffractive effects. But you're right, for broadband applications, we'll have secondary effects, but as long as we arrive to suppress the first order of diffraction, we will not get in trouble. And this is a question at the end of the angle of the diffraction of the first order. And you can suppress it as long as you keep under lambda over 2.
We have also optical cloaking materials.
Yes, optical cloaking is a typical application. There are researches, and there has been shown in theory and also partly in practice, but not of large areas. So don't hope that one day you will come in here in a coat and nobody will see you.
Invisible.
You will be. No, this will not happen in near future. But I agree, there are already cloaking structures have been presented in science. But it is a question of large area and large scale production and of money, of course. But in theory, it's possible. So you are maybe from the electrical department, so in the microwave structures, you can do this. You can easily do it, easily not, but you can do it. And I'm sure you can even do it for a student demonstration.
Thank you, sir, for this wonderful session. Please give him a big round of applause. As we come to the end of this lecture, we have an open discussion and feedback coming up. For this, I request our beloved principal, Dr. A. Unikrishnan, Dr. Mugundan, senior scientist from the Naval Physical Oceanographic Laboratories, expert from industry, Sri Samuel Vargas from Nest S4 Technology, and our student representative, Ram Prasad of S7 ECE Beta, to take their seats on the dais. May I invite Dr. Mugundan, NPOL, to share his thoughts on this session.
Yeah. Respected chief guest, Professor Pfeffer, Dr. Unikrishnan sir, and other dignitaries on the dais and off the dais, and also my dear students. It's a really great privilege that Dr. Unikrishnan sir has given me to come and attend this lecture of a very erudite lecture from Professor Pfeffer. And it's also some area which is close to my heart, because I am also working in the area of nanotechnology, but not exactly on optical thing, but other aspects also. So I would first give a summary of what Professor Pfeffer said, because it is a very interesting lecture. But to be very frank, I have some technical and managerial responsibilities in my national lab. So when Dr. Unikrishnan called me, I thought, it's an opportunity to come and relax here intellectually. It is kind of fasten your seat belts, sit back and enjoy, because that's what I thought actually. But then he came, he told me, no, you have to take notes and also summarize the lecture. So, but I found how interesting it was for me to take notes on a lecture from a really international expert, and also I can't say no to my mentor. So so I accepted it. Okay, so jokes apart, coming to this one, he gave a fantastic lecture about the nanostructuring for optical applications, especially on initially he talked about spin-on glass technology, where actually how the process of spin-on technology was being practiced in his lab, like sol gel technology and the colloidal sol gel technology, etc. And also initially he talked about the applications of Fresnel lens array, and then he showed through the SEM structures. I don't know how many of you really understood that. The way through the scanning electron microscopy can be used to actually study the structures at a very, very fine structure. He went down from a few microns, right up to 20 or 40 nano. It was a fantastic array of SEM pictures. Then he stressed on the defects, and Dr. Unikrishnan sir also mentioned, and he also mentioned about nature's wonder, that especially all these nanostructures have been done in nature. We have several such, the patterns on a butterfly's wings is of nanostructures. Then we have the conch shells, the moths, and so many other things. Of course, Professor mentioned we would all, in a similar situation, try to escape saying that this nature has done this over 1 million years or something. We can't do it. But I would like to say that from a mother moth to a daughter moth, it doesn't take that much time, but still we have similar structures. So we can never reach the nature. That's a fact. But it is, we are trying to do a lot of technologies now being done with the mimicking nature, biomimicking, etc. He then dwelled on the basic theory of optical grating, etc. One particular thing I found about his lecture is that, as Unikrishnan sir also was mentioned, even though he dwelt mainly on the experimental aspects, but he also gave the not just the modeling. Nowadays, it's a modeling an easy thing to do, but he talked about theory. Which was very appreciable. Then he talked about the design parameters, the importance of materials, and then importance of how important is the experimental methods to get these kind of precision structures. I'm just reminded of a story from our Hindu mythology. They say that the King Ravana, when his son was about to be born, he had this power of keeping all the planets in the right place, to have the best sort of stellar configuration, so he will have the best horoscope and and the best and will have a son who will be the perfect human being. Okay, so then it's said that the Saturn just stretched its leg into in a not so conducible column, so that he was a perfect man, but he became of very short life. It seems he died at the age of 32. Yeah. So same way, we do all kinds of precision experimentation, but then, as he said, there will be some leakage of oxygen or some other impurity into that. And then you will have another Meghanada. Then you will have another Meghanada born, who is not a perfect person. So it's why I say this is that we have a class 1000 and class 100 clean room in NPOL. So we work on this kind of technologies. We work on this kind of structures being created on silicon and other this thing for our kind of applications. So it is really, we can appreciate how difficult and what is the difficulty you have gone through. Okay, then he described this was followed by grating fabrication and through holography, holographic lithography techniques, etc. And then he talked about anti-reflection gratings in calcium fluoride. And then he came to my topic which is close to my area of this thing, that is non-wetting coatings, the lotus effect, etc. Of course, it was really an eye-opener for me that the lotus effect is not so good for precision this thing, because nowadays people talk about the windshields, for self-cleaning windshields for car, etc. And I thought it had perfect avoidance of scattering, but I understood that
on the level.
It depends on the level of and he then showed that how using a very ingenious chemistry that you can build up these and come out of the 193 or nanometer structures, so that at least the Rayleigh scattering can be avoided and all that. So overall, it was a fantastic lecture. I am sure you will all agree with me that it was a really time worth spending and taking notes also. Thank you very much for that lecture. So in NP oil also, I don't know whether sir has mentioned it any time here. We also work in similar areas. And sir mentioned about optical cloaking. We are also trying to work on acoustic cloaking materials. Yeah. So the overall, nanotechnology has really a wonderful field for people to enter into. But the precision that you can achieve really depends on how cleverly you do the experimentation. So that's why probably industrialists may not be very interested, because they only are interested in quick profits. Here it will be a little difficult. So I enjoyed this lecture very much. So and I also thank Dr. Unikrishnan sir and the Rajagiri establishment for having me invited here. So many of you, I don't know from what all backgrounds, but the other interesting thing is that anyone from any background can get into nanotechnology. I mean, that is a highly interdisciplinary area. Yeah. So thank you, sir.
Thank you, sir.
I've already asked sufficient questions and given my views also. It was a fantastic presentation. I must definitely thank Professor Pfeffer for the good presentation that I had. Normally, I used to feel a little jealous to this nano community, basically because every other day they used to have a symposium. Because then they used to go in large numbers, they used to attend symposium, and I used to wonder what these people are doing in the symposiums. But I find that there's a lot to discuss, because it's definitely a formative stage, it's an evolving stage, and I'm pretty sure that in the years to come, we'll have more interesting results in the nanotechnology. Of course, the applications are coming up, and of course, I'm not quite sure to what extent we'll be able to mimic nature. The bio-mimicking, of course, could be a bit of a problem, as Dr. Mukundan also has agreed. But let's hope that with all the concerted effort that we have with the nanotechnologies world over, we'll be able to accomplish something and then come up with solutions which are really good in various disciplines of human endeavor. So I would like to conclude saying that the presentation was excellent, and I derived definitely a lot of insight into the process, the fabrication process, and of course this concept of this wetting, that the lotus wetting, that I think is a very wonderful concept which I had I also thought so that lotus wetting is a good solution, but I think I must ask to be a little cautious on that. Thank you very much.
Good afternoon all. Professor, it was a very interesting talk, and you covered all the aspects covering the fabrication technology, and then two very exciting applications. In fact, both the applications you mentioned, we see a lot of potential, especially the grating. We see a lot of application in optical communication. I'm coming from industry, and we work in optical communication, especially in miniaturization and also in making rugged products. So conventionally, we depend on coating and or milling process to get such kind of gratings or other optical small optical devices. But I think this technology can give you more rugged solutions and also miniature solutions, which can be applied not only in communication but also in other areas like imaging and other optical systems. And recently we are fortunate to work in some sensor also. That is again a nano particle based. It's a quantum dot, which is basically embedded in fluids. Any type of gasoline or any kind of fluids, you can embed those quantum dots, which can be used for fluid tracking. And we came across some challenges, and I found this non-wettable coating as an excellent solution, because we read these nanoparticle reflections, fluorescence basically, which is embedded inside this gasoline tube. So sometimes some particles get accumulated on that, and I think this non-wettable coating will be an ideal solution for that. So in short, I found these two applications of this. I know there are multiple applications, but both these applications explained by Professor was very interesting, and I hope the collaboration between Rajagiri and this university will be very beneficial, and I wish all success.
Good afternoon, ladies and gentlemen, and thank you, sir. Thank you for coming here and for gracing us in this occasion, and we really appreciate it. So my thoughts on this discussion was that I believe that mimicking nature has been going on for years, and mankind has reached a point where we are seeing Australian scientists are working on bionic brain and bionic eyes. So we have come to that extent that we can actually imitate human beings and human eyes and brains. So we have come to that extent, we have advanced to that extent. So such advancements in nanotechnology and in photonics will definitely help in that aspect, in treatment and in detection of cancer and such reasons, because we have really small and particulate materials which we are injecting, and we are taking the readings. So that is one of the reasons. That's another thing that I found is very interesting. Another point is on defense. On defense, yes, sir had mentioned about cloaks, optical cloaks. But I'd like to highlight another fact that from DARPA, Defense Advanced Research Agency, and the Department of Defense in France, they're already working on cloaks for defense-based operations. And the trial run has already been completed. So they're using metamaterials which are at a nanoscale, and as of now, they've successfully done the camouflaging part in 5 different environments, with 5 different weather conditions. So this is one area where I feel such nanoparticle level technology will be really effective. And once it is implemented, that is a point where I feel whether this is commercially feasible. As an engineering student, as an electronics and communications engineer, I feel whether this is commercially feasible, whether this is whether we can replicate this at a larger level. That is one point where I feel we have to work on. And in the future, I think if we put our best efforts forward and integrate our research, then definitely I feel that we could come to a feasible solution which will be really good and in the advancement of this field. Thank you so much.